What is this? Okay. I can't read this. All right. Come on, man. Minus 9 times y plus t equals 0. This is a tough one. cosine. Is it not solid? We have to do Hey, how you doing, man? Can you hear me? Can you hear me?
Yes.
What's good? How's everything?
Yeah, pretty good.
Okay. Yeah, I sent you some of the solutions for this already. It's not this one. It wasn't that bad. It's just like there were a few like equations in here that were like quite difficult to solve. And maybe we can go over
Yeah.
those.
Okay. Yeah. I did as much as I could on the homework. But
Okay.
I was just there's only a few I could do completely. A lot of them I had questions on.
Okay. Which one?
And so that would be, let me just pull up the thing. I don't like how it always puts you on full screen every time and I have to go and hit window.
Yeah.
But
This one
um,
is due tonight, right?
yes. So this would be, it would actually be the second one I could actually do completely. It was the
Okay.
first one, was, the first one, but anyway. Also, when I tried to input the last two questions, the answers, it just said it was incorrect. The one that was like guess, and then the other one was
Oh, the guess one, number
yeah,
7.
number 7, and then the number 8, the match each differential equation. I'm just gonna pull it up again just to make sure.
Okay.
But um, it was just on the first one. Like so, I was just kind of didn't quite know how to deal with all of these multiplied to each other. Um,
Which number is this again?
for number 1.
Okay, number 1. Let's look at that one. Let's take a look at this. Okay, so this one, how far did you get?
So I filled out the Ronskin itself. I just did not actually solve the Ronskin because I didn't know exactly how to put those things together.
I see. Yeah, it's pretty difficult. I did use like a program to allow me to find. Are you looking at my screen right now?
Yes.
So like I actually got it to equal 0. So I think it's supposed to just look at these functions. They look like they're maps of each other, right?
Yeah, the plus 5 and the minus 5, sine 5x, and the plus 25 minus 25. Because I
Yeah.
know, like, if I were to do the third kind of operation when you're doing the 3 by 3,
Yeah. Yep.
you would just do the first two columns on the second and third rows. Um,
Yeah. You could do that one. If for this one, like what I would do like I guess you do have to like put that together. I'm just saying that like it does equal 0.
Yeah.
You probably still have to show your work. You know how to do the matrix, right? Like
Yes, I know how to. I know how to do the matrices.
for
It's just
determinant. Yeah. Okay.
yeah. It's just I didn't quite know how to actually solve this one, so I guess I'll just use a calculator for that one. So
Okay.
then the second one was okay, but then
Okay.
the third one, which was where you had to match them.
Okay.
I understood how to do the first one fine, but then when it dealt with a extra variable, especially the second one when it had to do with the denominator, that's where I kind of didn't know what to do. And also whenever you just have a t with the y, so it wasn't just I guess a separable case. I don't really know the terminology.
That one is a little bit like there's like different ways you could do it. You could do Laplace transform. Maybe I can show it to you. Let me see if I can. Hold up. Let me see if I can show it to you here. And see if we can. Because you remember I said that you could use Wolfram.
Yeah.
Maybe this is a good time to talk about it.
Okay.
Like, what I would do is like probably go like Wolfram right here. Like it's called wolframalpha.com.
Mm-hmm.
This is how if you're like stretched for time, like I would probably just do this, and then the way you solve this guy. For me, I have the pro version, which
Okay.
shows me the steps. Yeah,
How much is that? How much is that a year?
it's not expensive. It's only like $4, I think, for the each month.
Oh, okay. Yeah,
So
because I'm using this other program that's $20 a year.
does it solve it? Does it solve the equation?
I haven't had a chance to check. I just was wondering if you
Yeah.
like
So
just to go through this with you.
okay. Let
But
me just talk about this one first. Let's see if because like I did take a look at this, and how you solve it is how does your professor solve this one? First of all,
see, I don't know. I
did
don't
they
know
talk about
how.
it?
See, I would assume he did. It's just that I can't really follow the notes very well with how to do these problems. It's kind of like I just feel like he did an example of a problem, but didn't actually go through how to do this particular problem.
Okay.
Something that seems
So
familiar.
so let's take a look at this, and I'm just using like x instead of like t. So like, you know how this guy right here, you pretty much just saw it. And let me see if it shows you the steps, and then we'll talk about it because it's pretty long. Let me see. It says solve, but it doesn't tell you.
I mean, like I've already gotten these answers into the program, but I just
You have to get the
you need to
Wronskian
know the
inside.
steps. I just want to know the steps. Like when I say the program, I mean the online homework. I've already put in the answers in there and gotten full credit for it. It's just I'm
Oh,
just
you got the full credit for this one?
yeah. I just put in the what seemed to be correct for the answers.
Really?
Like yeah, because
That's
it's
good.
just like you choose the letter, so
Yes, you do
eventually
choose
you
the letter. Yeah. I'll tell you the steps. Like what I'm gonna do is because for this one it's a little bit different. You have to do reduce. What's it called? Reduce the
RF
method of no, that's not the one. Which one is it? Reduce.
row echelon form.
That's when you're solving the equations. It's when
Okay.
you have variable coefficients for a second, and this is what we have right here. Let me just look back to it. Because like the one that's easy to solve is when you have constant coefficients. Reduction of orders. It's called reduction of orders.
So is this what this subject is related to?
Yeah,
Because I was just having a hard time knowing exactly what to put in um, to
or like
solve.
how to solve for it. The way you out because like when you're solving a homogeneous constant coefficient second order differential equation, what was the method? The method was just you have those you have to make a characteristic equation, right? And then you
Yeah,
get
find the
general.
eigenvalues.
Yeah, but then for this one, like 2 and 3, 2, 3, 4, and 5, you have like it's not a constant coefficient now, it's like a variable coefficient, right?
Yeah.
And then the method for that now is called reduce of orders, reduction of orders.
Okay. So I just typed reduction of order into this other calculator, and it says you get, I don't think that's right. True for all y double prime minus 2y prime over t minus 9y equals 0. I don't know if that's a step that you had to do here.
You know what would be best is maybe if I write like the step by step for you for reduce of orders.
Okay.
I'll do that though. Like I have to look back to it, but I'll probably give it to you tomorrow. Like
Okay.
if I have like an example for it. But so I'll do like maybe like one of these guys, 2, 3, 4, or 5. These are pretty difficult. That's why.
Okay.
I'll talk about it though. The way you would do it is you have to you have to guess one of the solutions, like what the solution, and then like you have to substitute it back, and after you substitute it, you have to solve for that v, or like that new function. But I'll tell you the exact steps because it might be important for the test.
Yeah. I don't know if there's a difference between the fractional reduction of order versus a non-fractional, because there's actually 2 types for here. There's a one with a fraction and one without. So there's like the cosine is the only one that was there, so I assumed it's sine because when you do the derivatives, it changes the.
As I remember it, it's probably just the same thing. The only thing there is the general equation is if there's like a coefficient that's a function of t in front of like the differential.
Okay.
So like if there's a coefficient that's not like a constant, let's see. Let me go back to this one. Like every time you have this guy right here, these guys.
Yeah.
Like if they're all like maybe for example this guy is like a function of t, and then you have this q that's a function of t, and then r a function of t. These guys, if you have them all like a function of t, then that's when you apply this reduction of orders, and then you should be able to get like the same way as what we did here. But
and
it's a long ways of maybe I can like show you. Let me see. Yeah, maybe I'll show you also. There's actually a way here to let me share the other screen.
Okay, because it's really just this step, the first step, in what's different, because after that you just build the matrix and you still do it the same way. It's just this first step in finding the eigenvalues is.
Can you see my screen? Okay.
Yeah, Paul's online notes. Okay, yeah, I know this.
You know about this one? Yeah, that's my notes. Nah. Anyways,
it's everywhere.
So you see this reduction of order, right? Reduction of order. So like you look at this guy. This is the general form of the differential equation.
Yeah.
So like this is what you have like in all of them. It doesn't matter if it's a fraction. And then I guess we could like take a look at this example and then just try to explain it. So the thing is, you're given this t right here, right? And I think for all of these, you're supposed to be given one of these guys in order for you to apply the reduction of order. Like you're actually given like one of the solutions. For the one that we are given the solutions, right? But the thing is, they have to like keep on working. You know what I mean? I have to test all of them. You have to test all of them and see if you can get a solution, because you don't know if it's a solution. That's like. So you have to assume, like, the ones that are left. You have to assume that they're a solution, and then this is what you do. So you see this V. This is the one I was talking about. So you make the second solution. So y1 is the first solution, the one that you're gonna assume.
Yeah. And
then the second solution is like a function of the first solution. Does this all make sense a little bit?
Could you kind of repeat that?
Okay. So for example, if you have this given like variational coefficient second order differential equation, you have to assume a solution. So in order for you to apply reduction of orders, the first solution has to be assumed, and then the second solution is like a function of the first solution times like a variation of t. So like this. You don't get that one. Okay,
No.
let me rephrase that one. So you have this differential equation, right?
Right.
This, when I say first solution, does that kind of make, like, what do you know what that means? First solution.
First solution, is that just like the first derivative or?
Okay, no, it's you know how when you have a differential equation, just going back to what we know, like you know you have the constant coefficient. The coefficients here are constants. You know you have like c1 e to like whatever plus c2 e to whatever, right? Something like
Yeah.
that. The first solution is that c1 e to whatever term. This is that y1. This is that one.
Okay.
So you know you usually have like two solutions, right, or three. So this is one of them. This is one of them.
Yeah, there's three solutions here.
Yeah. So you have one solution that you
Okay.
assume, and then knowing that that's a solution, you build the second solution. You build the second solution as a function of the first solution.
Hmm.
And then you know all of these solutions have to be a function of t, right? You know that, right? Right? Like,
Yes. Yeah.
so if they're a function of t, you're just gonna assume that the second solution has also a variable coefficient. So this is a variable coefficient, right?
Variable coefficient. Yeah, it's a coefficient with a variable in it.
Yeah, it's not
Okay.
constant. So that's why you assume it, because that's what you're trying to solve. You're assuming that this one is given to, so you're just gonna assume it's a function of that guy. It's just an assumption. Like, why do you do it? It's just an algorithm. Like,
Okay.
this is how you solve these guys.
Yeah.
So,
So my question is in this example, they're giving you an assumption. But what about the case where you're not given an assumption?
so if you're not given an assumption, like not with our case, right? Like something else, because we are given an assumption for us. Like
Really?
you can assume any of the ones that are given, yeah. The ones that are given to you.
Okay. What
Oh,
would be the assumption here? Because I don't see it. I just see.
okay, wait, hold on. Let me take that back. They're giving you a Ronskin, right? I think
Yeah,
they give.
but I don't know which one because it's like there's two parts,
Let me go back to it.
The Ronskin and the function, there's two parts. It's
Let me
like we're only given one and we need both. So,
with Ronskin of one of their fundamental, match the same with what the Ronskin of one of their fundamental solution sets. So it gives you the Ronskin here. Okay, I see. Sometimes what you can assume, let me see this one. Sometimes what you can assume is gonna be one of the coefficients. See, like I said, like these variable ones are kind of abstractly, like you're like hand wavy. When you're looking at this guy, you can technically, like, if you could technically assume like maybe one of these, like it does, you know, maybe the first function is like t. You can take one of these guys, and then that's like a valid assumption. Like you just put this guy in here, like maybe t or 2t squared, but it has to be a function of t. Like for this other guy, you're given this guy, right? Their first assumption here, and they're assuming the first like solution is like one of these guys. It has to be like a form of like what you already see in your differential equation is what I'm saying.
okay. So you can just pick one.
You can just pick one and then go along with the method.
Okay.
It's like I said, like this one is, that's why I don't like doing this, because like how do you, they're supposed to give you like a solution already, and then that's how you end up solving for it. It's easy if they give it to you. If they don't give it to you, you just assume one of the variable coefficients that in your differential equation is a solution.
Okay, so
Okay.
does it have to be a t equals, or can it be something equal that's not just t? So like on number 2, it's 2 over t. Could you say 2 over t is a solution, or do you have to say 1 over t is a solution? Or but there's also an equal.
You could, it's 2 over t is valid.
Okay.
It's just pretty much, you know, it's a linear graphing of 1 over t, right?
Yeah, so in this case, you would have since it's y double prime minus 2 over t, y prime minus 9y equals 0, you could assume that y1 of t is equal to negative 2 over t.
Yeah.
Okay.
It's like one of those, like I'll clear those out if I once I do like each one of these like thoroughly. It's really like knowing, let's just go over the steps first. So you know, you have these guys, right? So you get this now. Like you have to assume something if it's not
Okay.
given, and then the second one is like a function of t of the first solution.
Okay,
And
so
then
you just build y2 with another variable with respect to t
that's the rule, yeah.
times
That's
equal
the rule.
solution.
The like yes, the second solution is a function of your first solution with a variable coefficient.
Okay.
And then the next parts are just doing a bunch of math. Like what you have to do is you have to get, like, you know, along with any of these, you always want to get like the second first derivatives, right? You're just gonna, from whatever you assumed, you're gonna do their derivatives. And then what they did here is there's actually a problem that you're given this, like you have to solve for alpha and beta. Do you remember that problem?
Yeah, that's also one I had a question on too, because the answer was correct, but I didn't know how to do it.
It's definitely a hard one. Yeah, that one's like it's kind of like an exam question because you have to do a lot of solve for this, equal this. Anyways, how you do that is kind of similar to what we did here. So do you understand up to this point?
Yeah, so you would just take your y2 and take it twice, because we have three
And
things. So
you do a bunch of like product rule. Yeah, just carry out this v of t, right? It's obviously a function of t, right?
yeah, so do you keep do you kind of ignore the variable and just solve it, or I was
What do
just
you don't really ignore it. It's like a function of t. So you do the product rule. It's not a constant. Like you know,
okay.
like obviously like this is a variable t times another function. So you do the product rule. Not the constant rule. It's like you do have to do the product rule.
Okay.
And so yeah, you do that, and then like the next thing there, those are like probably not like, it's not that bad. The next thing here is you plug your y2 all the way here in your differential equation. So this y prime and then y double prime, y prime, and y, it's going to be in 2 now. So the second, it's going to be this second solution. You just plug in what you just did. So the next thing though is you rearrange, and what you want to do here is after you simplify it, you're gonna get something really cool. Where was it in here? Yeah. So this seems like familiar. So like you're gonna get something that's in terms of that variable coefficient, right? And that's what you're trying to get, is like the variable coefficient, and then so after you simplify, you're gonna get something in terms of your variable coefficient. This guy, right? Like after you do all these simplification,
Yeah.
it's gonna be in terms of your variable coefficient. Like all of this, well, you know, once you do more problems, you're gonna see like, oh, okay, you get this guy, and then the next thing here is you have to do a change of variable, which is like, have you guys covered that kind of?
I mean, that sounds like U sub.
Yeah, it is. It is. The reason why here, let me say this because that's we can do it, and then we will solve this with making. The reason why you do this is what you do here is you just pretty much, you know how this is called a reduction of order, right?
Yeah.
You
I
have to
mean,
assume.
you would do the same kind of reduction to change a variable as you would like finding your lambda values or your k values.
In a way, yeah, in a way.
Okay.
So like what you have to assume here though is you're gonna assume the w's are like one differential order. Like it could be, you know, another variable. You can you're gonna make a change of variable where this new variable is gonna be the you know the variable coefficient, but then like one less derivative. This is why it's a reduction of order, because you're gonna change your variable so that you can reduce your derivatives.
Okay.
Does that kind of make sense? That this is where the part that makes sense, because then this is a reduction of order, and then reduction of derivative order. So with that, you know, just going over that steps again. So you know, like you assume that first solution, right, from the differential variable coefficient terms, and you know get a second solution that's a function of the first solution, but then you also need to put in a variable coefficient, right? And
Yeah.
then from that, you just take all its derivatives. The reason why is you're gonna plug them in here in the differential equation. And then once you simplify that, you're gonna get the equation in terms of your variable coefficient term, which is v in this case. And then after you see that, you're gonna apply a reduction of order by assuming a change of variable that's gonna be one less order than your variable coefficient. Yep. And I think that's where we're at. So that's after you do that, then you get this guy. And I think you can solve this now, right? This is just a linear first order.
I mean, yeah, there's still a whole part where it says 2tw prime.
Yeah.
Does
That 2t, that 2t.
The t, does that t disappear, or it get
So
turned into something else?
so let me see. Like this is the part where like so if you remember,
No.
do you remember doing a first order?
No.
Okay. See, like
That part, I think that was before we started doing the meetings and things. Almost all topics so far that we've covered, I'm being honest and serious, like I don't get.
okay. I'll talk about that later. That's the part that okay. Now I know what to write on my on that list of things. I'll actually solve it and then go through the process of the first, because that's what you have to do. The reduction of order means you're solving a second order differential as a first order. But then the first order with a variable coefficient. This guy. Does this seem familiar? At least?
Dy dt. Yeah, but I can't remember what type of equation that is. Another.
Do you remember this? Yeah. Okay. Let me just talk about it. So this is the equation, right? Typically for first order. Yeah. This first order, this first derivative doesn't have a coefficient, but then this one with a zero derivative, it has like this variable in here.
Okay.
And then you have to apply this integrating factor here. I'll talk about it.
Yeah, integrating factor. That sounds familiar. Is that the integral of some variable with the derivative? It's like the d something.
Yeah. Let's talk about it like not the the generic way. Let's just give an example.
PT dt.
Yeah. Let's use an example to explain our steps. It's
Okay.
easier to. So for example, you have the first order differential equation, right?
Right.
And then so what I would do here is like I put everything to the with a variable to the left. And then this is what I usually do. And then you need to know what your PT is. So PT here is anything in front of the zeroth derivative, right?
So PT is everything before. Okay.
Yeah.
Let's see.
PT like meaning the term that's in front of your zeroth derivative term, the one without a derivative.
Front of variable. So can you have a variable as your PT, or is it always a numerical answer?
It can be a variable. It can be a variable. It doesn't have to be a constant.
Okay, so let's say you have two variables like an x and a y, and you have to, let's say that's the form where you can determine your integrating factor. How do you know which one is the variable as part of your PT?
What do you mean? Like you mean like if you have like an x and a y, like two variables?
Yeah, like if you had like a 0.196 xy in there.
X times y.
Yeah, x times y. Which one would it be? Would it be
in this case? It doesn't matter. It only matters if it's a t, right? Because x and y in this case would be a constant, right? Like this, you're integrating this in terms of t.
Okay. So you could have a 0.196 x dt. You would just differentiate that with respect to t.
dt. Yeah, which is like that would just be 0.96 xt, right?
Yeah.
And then so you do that. If it's a t, it doesn't matter because you're just doing this integral.
Okay.
And this is the part I wanted to look back, because then this form is very easy. It's like this is why they want you to go back to this. Like this is the reason why they want you to solve the second order with the variable coefficient as a first order with the reduction of orders, because you already know the solution to the first order. You just do this, the integrating factor, right?
Yeah.
And it's pretty easy. Like the PT, you do like this guy is like e to that guy, and then this you times it, right? You pre-multiply everything by that guy. Do you remember doing that? you pretty much pre-multiply everything by this guy, and then you know you do this.
Yeah, that's the yeah. You would multiply everything by the integrating factor on every term.
Yeah, and then like so this becomes 1. This is 50, and then this guy has negative. This looks familiar once you
Yeah.
like look back like, oh, okay, now it makes sense. Okay, so let's try to apply that to what we were looking at. So you reduce this, right? This is the one that we had before. You reduce this guy,
Okay.
and what I would do here is like I would probably divide it by 2t because you want your first coefficient here to be 1. You want your first derivative to have a coefficient of 1. Okay. So I would divide everything by 2t, and then your pt would be negative, right? Like you want this to disappear, right?
Yeah, so you would just have a w prime minus 3w over 2t equals 0.
Exactly, yeah. And then that's why they have this guy. And then so you do the exact same steps, w prime minus 3 over 2t times w equals 0. The pt is minus 3 over 2t, right? You integrate that guy, right? I'll show you the steps once I'm like writing. You integrate that guy. After you integrate it, you're gonna get this wt after you pre-multiply, with a constant, obviously. And then, you do the same exact algorithm as with the first order until you get a solution for that change of variable. This w was the change of variable, right? It wasn't what you're solving for.
Right.
So now you have that. It's kind of like u sub. You put everything back in place, right? It's kind of like u sub. So now that's it. You change your variable. Let me put it back. Let me get the v out of that. So what do? You have this w. You made w as like the first degree of the of v, right? The first derivative of v. So you just have to integrate it, obviously, right? You just have to integrate this to get v. Integrate w to get the v of t, right?
Yeah.
And then w, you just solve for it using integrating factor. And then so you do like integral. It's pretty simple. You get a constant, obviously.
Okay, so since we know that our w is our ct to the 3/2, do you replace that w with the ct to 3/2 before you integrate it, or do you just integrate the w and then plug in
Okay.
after?
No, don't do that. Like I would.
Okay, you put it in before.
Yeah, because obviously it's only a function. It's like arbitrary function. You want it to be the real function, and then you do the integral, yeah.
Okay.
Okay, and then so let me look at this. So just either
repeated roots.
Let me read this one. So most general, we can use this again. So just read this repeated roots. Let me look at this repeated root. This is like going back to remember that there's the repeated roots, not distinct roots for second order.
So
the second order, you have distinct roots, repeated roots, and complex roots.
Right. Okay. The 3 types.
Yeah. So this one, I guess let me see what they want. So they're saying here that they chose the constant. Okay, after you choose, so pretty much this thing disappears, right? They just chose the constant c and the k, or c. This can be c1 or c2. It doesn't matter, right? C1 or c2.
Okay.
And then what they did here is this is what you do, like you try to eliminate these guys until you get like an actual v, because this whole thing is v. This whole thing right here is a v, right? This is vt. And then what they're trying to do here is I want to eliminate all these integration, like this c and then the k constants. I want to integrate.
Why do you know that whole thing becomes vt when you're like the line below it says vt is equal to t 5/2? All I see is just one part of that.
Let me explain it. So like this is a construct. It's like something that you do just to simplify it. You usually do this every time. Like you're gonna do this same with this one. You're gonna do this every time, and it's just a construct. Like why are you doing it? It's just because it simplifies your solution. So going back, do you understand up to this point, like where we plugged in and we have this integral, right?
Okay.
We have this integral, so we know how we got this, right?
Yeah.
Like, but then how did we get to this guy, right? How did we
Mhm.
get this guy to this guy, right?
Yeah.
How we got that is the C and the K. This can be anything. Like these are just, and that's what they're saying. It's like an
Okay.
X. It's just any constant you want. You can choose
Yeah.
any constant you want. So choose the constants that will make it disappear. You know what I mean?
Mm-hmm.
Like K, in order for K to disappear, you choose, like I said, like why are you doing this? It's just the algorithm. Like it's just the way like you solve for these guys. That's why like this differential equations, like why are you doing, like someone created like an algorithm one day and then decided that it works. And this is the reason why, like when you make these ones equal like 0, you're simplifying it, and you make this 5/2, you're gonna cancel the 2/5, right?
Yeah.
You're gonna cancel the 2/5, and you only get 1 as the coefficient,
Mm-hmm.
right?
Right.
So now VT is this very simple one, and then you want to get the actual VT was just something, right? It was just the thing that we chose to be in front of this guy. Do you remember this one?
Yeah.
So you have to plug it back in. So you plug. So what was y1? Y1 was this guy, right? The t. This is y1, and there's VT, and then so your second solution becomes this guy, t to the 3/2. So your full set is this guy. So you have the first solution, y1, and then y2, and then from going back to the homework, what you have to do is
Okay.
like you need to find the Wronskian of this guy.
Yeah. So how did that combine to get the t to the 3/2?
T to the 3/2, this guy.
Yeah. So how did those two combine together? The -1 to the, like the t to -1 times the t to the 5/2. How does that combine to get 3/2?
So like 2, right? 2 -1 is like 2/2 plus 5/2
2 plus 5/2. Okay.
is like 3/2. This t -1 is the y1 that you assume.
Mm-hmm.
You assume this guy because it's a solution, and then y2 is like a function of y1 and v of t, right? This is v of t.
Yeah.
Which is this guy.
Mm-hmm. Okay.
And the reason why, because like the whole entire time, the hardest part is finding v of t, the variable coefficient. That's the hardest part. After you get the variable coefficient, you just times it by like the first solution, and then you get your full set of solutions.
Yeah.
Do you want to do another one?
I don't know.
What do you think of this, like the steps for this one?
It's a lot of steps. I guess
It's a little weird though, right? Like the steps for it is a little weird, right?
Yeah.
Like I would say the constant coefficients is the most common thing you're gonna find, and that one makes sense, right? You have like 3 different routes. It was a distinct real roots, repeated real roots, and complex roots.
Mm-hmm.
That way, that one makes sense. Once you get something like this, the reason why it's a little bit hand wavy is this thing right here.
Yeah.
Like when you're assuming something that's like given this guy.
Yeah, I'm pretty okay with assumptions. It's just trying to understand how to put the other things together.
Like which parts?
Just that's the procedure. Knowing, I guess, the order.
Okay.
Which I mean, it comes with, I know it comes with practice, but
Yep.
just
Yeah. You got it.
just from starting here, I don't know.
I would probably like I'm gonna see if I can do something similar to that with like 2, 3, 4, and 5. Maybe I can do those 2, 3, 4, and 5. And you got them already, right? You got this correct, right?
Yeah, I got the credit for it. So I guess, I'll look through this website. Yeah, because this week there's no new videos. It's just a review for the exam next week.
When's what day's your exam?
He's basically just asking us like when is the best time, kind of thing. He didn't give an
You guys should
actual
say like Friday. Can you guys do Friday?
maybe. Oh, I don't know. I'll have to
Okay.
see. I know that like on number 4,
Okay, let's look at that.
part 3 is
Let me look it
false.
up.
Yeah.
Let me look at this one. Okay, let me see. This one, I think it wasn't that bad. Let me just take a look at it.
Mm-hmm. It's mainly substitution stuff.
Number 3 is false.
Number 3 is false.
How did you get that one? What about everything else?
Everything else was correct. It just marked that as incorrect.
Okay, there's some. Let's try to read it. There is some second order linear satisfied by both functions, f1 and f2. Okay, f1, f2. And then the Wronskian is not equal to 0, right?
So for Wronskian, yeah, you can't have a 0. Is that for first? Does it matter if it's first or second order?
What do you mean? Okay, second order.
Do you only do Wronskian with second order or higher, or can you do it with first order?
Oh, I see what you're saying. There's some second order linear. I know for a Wronskian, you could do those for like it's a general term, you know.
Mm-hmm.
Like it's not like it only works for like sorry, because like the main reason for it is so that you can find like a linear is something linear like dependent or independent.
Mm-hmm.
So, but for the most part, I've only seen it for like the second order. I don't think it didn't come up because like what would your 1, 2, 3 F1 F2 yeah, what would that be? I never done it for like the first order. You know what I'm saying? But I know it works. Like it's just a differential term. But I don't think it's that one though. I don't think that's the reason why it's like false.
Okay.
Let me just see. There's some second order homogeneous equation satisfied by both.
I mean, it says some.
Yeah, it's like one of those things. T squared. If it's not equal to 0, then that means it's linear independent. F1 and F2. Satisfied by both functions. Or is it because you don't because you know how like 1 and 2 the first one is true, right? Like knowing that t equals 4.
Yeah.
But then if you plug in 2 equals or t equals -2 or 2, it's linear dependent because it equals 0, right?
Mm-hmm.
So I think it's very because like it's not for all t.
For all t, what do
It
you
doesn't
mean
work.
by for all t?
It doesn't work for all t. It's not like it's not a constant.
Yeah. Okay. It's a very vague kind of thing. It's saying there's some.
You know how like when you look at this Wronskian, like you've calculated Wronskian like for ages now, right? Like we've been doing Wronskian for like since like 2 weeks ago. But you know how like the Wronskian, it's usually like a number.
Mm-hmm.
But then again, like sometimes we sometimes get Wronskian as like a function, right? It's a function. It could be a variable. But I think one of the reasons why is if you look at 1 and 2, like for example, the 1, it doesn't match with the results of 2, right? It doesn't. Like if you make t like for certain t's, it could be linear independent, and for other t's, it could be linear dependent. But if you're gonna say that there is, like for number 3, it doesn't specify the t. It just tells you there is the second order that satisfies both functions f1 and f2. I think they're saying it's false because they didn't specify a t. It's not set, and I think that's why it's false.
Yeah, it's kind of like the word or actually it's like this word and. Like, you know, you can make a square and a circle, like with optimization problems and stuff.
Yeah.
Means an or.
I don't like these ones that much, but yeah, it's only one of them. You got all of them correct except for one.
Yeah. So I guess it's just like that some meaning any, I guess.
Yeah. Does it tell you the answer though? Why?
No, it just says false or true. It
Okay.
just says
Maybe
incorrect.
try to ask your professor about this.
Okay.
Yeah. My way of like explaining that is because it doesn't satisfy the Wronskian for all t's, only for some t's.
Okay. That makes sense. For the next problem, number 5. I understood everything about you take the derivatives twice and then you plug in your values, your first and second derivatives. But it's to that part after you plug in everything. How do you simplify it and cancel stuff out?
Okay, let's take a look at number 5. Oh, this is a fun one. So yeah, so let's just go over it. So you said you got everything to like plug in, kind of like what we talked about, right? In the reduction of order. You
Yes, I
plug it
mean,
in, and
I
then how do
just,
you? Okay, this part, right? This part.
yeah,
So this part is a little like you really have to go through like it's kind of like a linear system of equations, right?
okay.
But, or a system of equations. You just solve for like the variables. So like you know how to group them like this? Do you know how to group with variables like this and solve for them?
So let's see, A, B, so the t squared is a common factor with A and
Yeah.
B.
Same with it. This is usually the way I do these things, and this is how people usually do them. Like you have so many variables here, right? Like there's so
Yeah.
many things happening. So the best way is just to group them by a common thing, like t squared, t1. That's the polynomial, right? All these guys are the polynomial terms.
Okay, and my question is why, because I mean, you put stuff out in the kind of out of the equation, because it seems like there would be more alphas and betas than written there.
In like when you're doing this thing, like you're saying there should be more here.
Yeah, also are also just having a hard time. So which ones of those are B's and which one of those are betas?
Okay. So yeah, I'll write better next time. But the beta ones are this is beta, the one I'm circling right now. So
Okay.
and then the B's obviously they have this B0, right? The
Yeah.
B's have B0, yeah.
Okay.
And then so wait, I just want to know, do you know how to get to this point though? Like from what we got? Like you grouped them, right? You plugged it in the differential. Because this is important, like the way you get to this guy.
Yeah, before you get to that, I understood about the to get that long equation.
This guy.
Yeah, with the parentheses before you started grouping them.
This guy.
Yeah, I understood everything there. It was just the next part that I didn't know how to do, the cancellation and
Okay.
factoring.
How you do this, the easiest way I can say is once you plug it in, once you plug it in this guy right here,
Yeah.
uh, is just FOIL them out, FOIL all these guys out.
Okay, so distribute everything. Okay.
Yeah. That's the best way. I never work with them when they're like not distributed. And this is how I got to this point. Every term distributed to everything. And then, you have this, right? Like just check this out. You have like, let me see if I have it. Okay. So you always work with this, like you have a left-hand side and a right-hand side. Just take a look at this.
Mm-hmm.
So you know how like the left-hand side is all this differential equation, right? And you plug them in and you get this guy, right? Right here.
Yeah.
And then this right-hand side, you only have terms of t and terms of E3t, right?
Yeah. With the E3Ts.
So in my mind, this is all up to the mathematician or whatever. Is you can make your own variables here, like for example, t squared, but then it's 0 though, right? Because you don't have it, right?
Hmm.
And then but then t, you have a t, so it's 1 in the coefficient, right?
T is 1 in the coefficient. What do you mean?
Right here, look at this guy. You have t, right? Like it's t, but there's a 1 here. There's a 1 coefficient in front of the t, right?
Okay, where exactly are you pointing on the screen?
This guy right here.
Okay, on the very right. Okay.
Okay, this guy right here.
Yeah.
So if you look at this, remember, this is like a math trick, it's like another math construct, like a math strategy to make, to solve an equation.
Okay.
You initially have this as your right-hand side, right? T plus E 3t, right? To the 3t.
Mm-hmm.
It's a math thing to do to like expand this to doing like 0t
So
squared,
T
right?
squared.
Plus 1t. It's equivalent, isn't it?
Yeah.
And then you do what? You do like 1e 3t, and what's another one? Maybe. And then you're probably wondering, how do you know which ones to expand it to, right? You're wondering, right?
Yeah.
Like that question is all up to your left-hand side. It's all up to your left-hand side. So, as I said, you have to like distribute all these guys, right? Make
Yeah.
them all a term. After you distribute them, try to look at a pattern. You have to recognize there's a pattern in the left-hand side. So the left-hand side, you're gonna see that there's gonna be these terms: t squared terms, terms without a t. There's gonna be t to the e3t terms, and then there's gonna be t terms and e3t terms. So whatever terms you have there, this is the reason why you have to add them. But then the coefficient is 0. Does that make sense?
Yeah, but like, how did you add the plus T e to the 3t when on the right there wasn't that there? Because I know you can like, I understand the zeros because I mean zeros cancel out, but it's like it
Okay.
doesn't exist. But like, how did you go from just T plus E3t to also having a T plus E3t plus TE3t?
It's 0, 0. This is a 0 right here.
Okay,
Sorry.
plus 0. Okay, that makes sense
Yeah,
then.
yeah. As I said, yeah, like that's what I'm saying. Like anything that is not there, you just make it a 0.
Okay.
And so that makes sense, right? That's the construct. Like you can do that. It's equivalent to this
Mhm.
guy. And the reasoning for that is so that you can group them. So now with that, does this make sense?
Yeah,
Grouping them.
I guess so. I don't really know.
See, like you could group them like this, right? Not, the ones I have right here
T
are
squared
pretty.
T1 E3T.
Yeah, there's gonna
Okay.
be. I forgot to add these terms, but there's supposed to be this E3T term right here.
Okay, yeah. So you always have to have on both sides. Okay.
Yep, because they cancel out, right?
All right. Take a screenshot real quick of that.
Okay. This
Okay.
is a math construct. No one's gonna tell you like this has to be done this certain way. There's multiple ways of doing this, but this way works. So
Okay.
okay, so accepting that this is like a step that we should do. Obviously solving this is easy now. You just match it, right? You just match the terms, solving it like an equation, a linear system of equation.
So it's A1 times beta. Okay, with the T squared.
And then how I would solve, because like what was the goal? You have to solve for alpha and beta, right? That's the goal, right?
Mm-hmm. Yeah.
So I wouldn't even care about these other ones, A1, A naught, B naught, all these other ones. It doesn't matter for you. I would just look for an equation that you can solve these guys easily. And then one of them is this guy, right? You could solve for beta easily.
What do you mean by you can disregard them here?
Where does it say disregard?
Well, you told me that you can disregard the alpha and the beta in the equation.
In the let me see. Where does that say that?
Well, it doesn't. You didn't write it anywhere, but you were kind of explaining about what you can do to get from that step to the next step. Something
Oh,
about not
okay.
accounting for alpha and beta. It
You
doesn't.
do account you do account for the alpha and beta. Well, what I'm saying is you don't need to solve for A1 and A naught and B naughts. You don't have to.
Oh,
These
okay.
you have to solve for alpha and beta.
Okay.
That's what you're at. That's what's being asked. So I would just look for an equation, and after writing these couple of equations, I would look for an equation where you can solve for alpha and beta easily.
Mm.
And then one of them pops out, the very first one, right? Because this very first one gives you this, right? A1 beta equals 0, right? It gives you that term.
Hmm.
And then, does that make sense?
So in this case, you're just saying since they're both equivalent to t squared, or they're being multiplied by t squared, you can kind of just set the stuff in the brackets equal to each other.
Yeah, you haven't done this one before, like this, something like this.
No, I don't think so.
This is a math construct. Yeah, like I guess you know how like you solve. This is a way for you to like. It's kind of like the term of like grouping like terms and solving for, because even if you do this, like, because it's an equation, right? The right hand side equals the left hand side, right? Like the left hand side term is 0 to t squared, and then
Okay.
the left hand side term is alpha on a a1 beta times t squared, right?
I mean, yeah, the closest thing we've done is we just like find like terms like you were saying, the way you were writing it, but we were like
Like term.
adding them together. So like if we knew that there was a t squared on the left side, we would just have t squared times in the parentheses and then move on to, and then, you know, the next thing that's common, but you just
Yeah,
add them together. Um,
I see. I know it's a little bit like this is valid though. The obviously the answer is correct, right? The the way I'm doing here, this is what you usually do if you have like a lot of terms, and
okay.
then because you cannot solve, you can't even solve for a1, right? You can't solve for a naught or b naught. There's like so many things happening here. So this is usually this is valid every time you have something like this. You can make it, you can expand the equation on the left, on the right hand side, such as this, and then if they share a common factor or term, that must mean
Yeah.
their coefficients are the same because they're equal. It's equivalent right here.
Mm-hmm.
And this is kind of like a linear algebra thing as well, because then like you know how these guys become kind of like, you know, when you have like ax plus by equals like c, something like that,
Yeah.
and then these a's and b's, yeah, I meant like the not those guys that you can solve for. I'm actually gonna, I think, I don't know if I did that here, the echelon. I did an echelon thing somewhere. It wasn't in this one. I was doing like some linear algebra to solve for like one of these guys. Anyways, the reason why you could do that is because they share a term here. All of them share a term, so that must mean even the equation itself, it cancels these guys out. That's another way of looking at it. They cancel out because they're in like both sides of the equation, right?
Yeah.
So if they cancel out, then their coefficients have to equal each other. That's just something that everyone will end up accepting. It's something that like it's a math thing to do.
Okay.
Sometimes it's like there's no physical way of explaining that. It's just like, okay, like it's a math construct and it works.
Okay. And so whenever you were mentioning about why you can disregard the A1s, the A0s, and the Bs,
Yeah.
things like that, why, like, how do you, knowing that, how would you solve this?
Okay. So for example, there's another way you could look at it. So just going back to this equation, right? This is this guy right here, right?
Yeah.
So the particular solution tells you that that there's this A1, A naught, and then B naught, right? Right? They tell you that one, right?
Okay. Yeah.
And because it's a particular solution, this cannot be zero, right? You don't have to solve for it. You just have to logically think about it. You don't have to solve for it because like what you're trying to solve for are these betas and alphas. So A1 can't be zero, right?
So how do you know it's not it's non-zero?
It's non-zero because then you're discounting the solution. You're discounting this t squared. You know, there's A1, and you have like A naught
Okay.
t
Yeah. You
plus B
can't.
naught.
Okay.
Yeah,
Because
like
it's attached to stuff.
yeah, like it's a solution. It cannot be zero, you know?
Yeah.
So for that, then the only thing that works is beta has to be zero. If A1 can't be zero, then beta has to be zero. So you solve one of them. That's really easy because it's like that's like one half of it. So you solve this guy. The alpha one is a little bit hard. You have to like look like, can you solve for it using the second equation? And I didn't. I think I couldn't find one in the second one, and I think this one doesn't also work. But when I take a look at these guys, and I took a look at these guys,
Mhm.
I was able to find like an equation, and that's what I did here, right here. The B naught one. If you look at the B naught equation,
6b naught.
these equations right here, the beta right now we substitute for that and it equals 0. So you only have like 2 terms for each equation. Does this one
Okay.
make sense?
No. The 6b naught or the. So what equation are you referring to here? Because are you
This
looking
guy?
at the top one?
No. Here, hold up. Let me change something. So I'm talking about. I'm
So
talking
I know
about
it's the bottom two you're talking about, but
these guys. Yeah.
yeah. So which one of the two in that
No,
selected one?
both of them. We're talking about both of them.
Okay.
These guys.
Mm-hmm.
These guys. So because we want to solve for alpha, right?
Yeah. I mean, yeah, because we determined beta had to be 0.
Yeah, and then you have to find like a logical way of solving for alpha. So you need, I got this equation, like these 2 equations, and then I just substitute beta in there. So beta is gone now.
So you replaced beta with alpha, or you replaced alpha with beta?
No, like beta is 0, right?
Beta's 0. Okay,
Yeah,
so then
we know that one.
you replaced it with something else?
No, beta is still 0.
So beta's still 0. Okay.
These are all B's. These are not betas. These are B's.
Okay. B0.
There was a beta here, right? There was a beta in front of this guy. If you remember, this guy had like plus B0 beta, but I just took it away. It's 0.
I don't know.
Right? There's a beta here. There's a beta term over here up top.
Beta term.
There's a beta term up here, the second equation.
Second equation.
Let me rewrite this one. So like if you take a look at, you know how like we have this here, I'm gonna write it right here. 6b naught, right? Is the first equation plus
Mm-hmm.
b naught alpha equals 1, right? Alpha equals 1.
Yeah.
The second equation is 9b naught plus 3b naught alpha. And I'm gonna write down here plus b naught beta, right? Equals 0.
Yeah.
So beta is 0, right? Isn't it? That's what we solved for.
Beta is.
It's 0 because
Beta 0.
we solved for it right here.
Yeah.
Beta equals 0. So let's just plug that in. So we got that one. And then so that simplifies our equation, right? We only have 6b naught plus b naught alpha equals 1, and then 9b naught plus 3b naught alpha equals 0, right?
Yeah.
And then from that, you just solve for alpha.
Okay.
This is a linear equation, right?
Yeah. So you could look at the top one. So you would have B
Whatever
naught
fashion.
B naught
Yeah,
alpha equals 1 minus 6 B naught, and then you could just divide out the B naughts.
exactly. Yeah, and whatever fashion you want to attack that, you should be able to get the same answer.
Okay.
You should be able to get this guy.
Yeah. Okay. It was just that middle part that I didn't get, but everything else makes sense, at least right now.
This one, I think it doesn't seem that like far stretch to like do this in an exam. I think you should do this one again like multiple times.
Yeah.
Because this isn't that bad. Oh yeah, in terms of like the exam, you should definitely like, like you already know first order, right? First order, and then second order. I'm pretty sure that's gonna show up.
Of course, yeah. I was just at the very beginning. One thing that was really bothering me the first week was identifying the type of equation, whether it was separable,
Separable, okay.
separable like I don't know the other ones. There is a bunch of other types. Like whether
Okay.
it's linear or nonlinear
Let
or
me just let me take a look. Oh, linear, nonlinear is simple. If something is like nonlinear, you're gonna have like terms equal, what I mean, like E, like that guy. This is nonlinear, right?
yeah. It was just the types of differential equations didn't I really could not follow what he was saying. Also like turning it into the like I guess making it into the standard form. I don't really know the
Standard form for what
terminology.
one?
Like
Which homework is this?
I think that was the
Or quiz?
first
Which quiz is this? I meant.
I don't know quiz, but the first it would probably be the first one, at least for the homework. Let me see.
Let me see. I have like so many files in there. Let me.
So,
Did you send me those ones?
yes, I did. Let me see. Quick problem
Is
one.
this not even the one?
Okay, yeah, like put the differential equation into the form of y prime plus pty equals g of t.
Yeah, that's the first order, right?
Yeah, it's just like the first step of when you solve these is you want to make sure they're in the correct form.
Yep. Because that's how you
That
solve. That's how you solve for it. Yeah.
okay, that's what I was having issues with. Yeah, like whether something's homogeneous or non-homogeneous, linear, nonlinear, any of those types of
Which equation is this? Which not equation. Which homework? Homework one,
homework
two.
one. That was
Let me look at.
problem one.
Okay, I'm looking at it right now. Let's see. Problem one. It says put the differential equation in the form of y prime plus pt. This is like the first order form, right? And
Yeah,
find pt and g. So the way you would do this, actually, let's just go over this one. Let me share this screen instead. I was doing some coding earlier.
nice.
Okay, so yeah, there's a lot of like that, this year. Okay, so for this guy, like this form right here, we talked about it. Like that's when you get like this PT and then this GT. This is really just algebra, Like what you have to do here is just algebra, right?
Okay.
You know what I mean? Like so you have this y prime and then y right here,
Prime and y.
and then that's the y prime right here, right? Can you? It's not too small. Okay, you can say okay. This y prime right here, and this y.
Mm-hmm.
You have to get it in that type of form where you have this y prime all by itself, and then this y with a pt in the front. And I think let me see what they put over here. I didn't really do this one, but it makes sense. This is the pt, right? And then everything to the right is gt. And then this gt is this gt right here is, let me see.
GT would just be
So there's no y term on the right side, is what I'm saying. If they're multiplied by y, they have to be on the left-hand side. So this cosine t.
yeah. That would
This
need to be brought over.
no, like the cosine
Oh,
t. This cosine t
oh
can be
no,
on the.
only the y. Okay.
Yeah, it's only the y. The y, because it's not multiplied by y. That's how you look at it. If it's not multiplied by y, or it doesn't have to be multiplied, but it's not like in the same term. Like for example, this guy right here, right? This guy.
Yeah, either 2t over y.
Yeah, this guy right here there's a y here, so you have to bring it to the left-hand side.
Okay. And I know you have to add it. And so I guess the problem I was having with this one was because I know that you want to get rid of that fraction on the left side, but the y, it's not being added, it's being divided. So I
I
didn't
would
know.
probably I'll probably times it by the bottom term, something like that.
So you would just multiply it by its conjugate or
Like you can multiply it by its reciprocal,
so that
um,
t4 minus 8?
and then and then with that, then you kind of cancel out the bottom, but then on the right hand side, you have to transfer some terms over to the left hand side. If because like then you'll have terms on, because you have to multiply them by the same term, right? You have to multiply these guys by the same term.
Yeah, and when you do the conjugate, you would multiply that with, its reciprocal or whatever.
Yeah,
Yeah, it's like I know that, but like how would that turn into um an
like
addition?
this form right here.
Yeah, like because
You
it's
have to
just a multiplication, how would you turn it to addition?
you have to do some like a bunch of algebra.
Okay.
This one, the way I figured like doing this, I would probably just like always get rid of these terms at the bottom because it's y prime and y can't be in the same like term. You have to separate them somehow.
Yeah, and I think he's gonna give a review, so
Yeah,
I
can you
think
give me that one and then that
yeah,
one definitely.
whatever he does. Yeah, because I don't know how to tell the difference between, the terminology of the types of differential equations, the
Oh yeah,
homogeneous,
and then this.
non-homogeneous, linear, nonlinear,
Let me just answer this one. So he's
separable.
asking here: is the differential equation linear or linear non-homogeneous or non-linear, right? And
Yeah.
and the answer is linear. Let's look at that y first.
Okay.
So this guy is like linear because you don't have a y prime squared. You know, there's no y prime squared or y squared, right? It's only to the first power, right?
Okay. So that would be linear.
Yeah, and this is non-homogeneous because look at the right hand side. Like you can't make this like zero right hand side, right? You have this cosine t somehow. So
Hmm.
like when you have a non-homogeneous is when the right hand side, the term that doesn't have a y multiplied to it, the gt, right? It's gt. If
Okay,
this
GT.
gt is generic, but it could be cosine, it could be anything, one, two, whatever. If gt is zero, that's non-homogeneous or non-homogeneous.
Okay.
If it's if it's if it's zero, then that's homogeneous.
Okay, so what about for in the case of like some exponential, like an Euler's variable or trigonometry?
On the right hand side,
Yeah.
gt, it doesn't matter. It could be any function. If there's a function there that's not zero, then it's non-homogeneous. If it's zero, it's homogeneous. That's the definition.
So basically anything that's non-zero.
Not zero, yeah. If it's zero, that's homogeneous. If it's anything but zero, it's non-homogeneous. And
Okay.
linear means if your y prime, all your y terms, the one that you're taking that you're taking a derivative on, you're right. You're taking a derivative of y, right? With respect to t, the thing that you're taking a derivative of, if that term is raised to is not raised to like a second power or greater, then if it's not raised to that power and it's only a first power, like what we have here, that's linear. If it's raised to like a second power or greater, it's nonlinear.
Hmm. You mean second power or second order?
Not second order, second power.
Second power.
Yeah, let me show you what like a non or hold up, linear and non-linear. It's always good to know these definitions.
Oh, yeah, definitely.
Definitions are the ones that like teachers like you to test you on, you know. let me look at this one. How can you recognize if something is non-linear? Y
Okay.
prime. Okay, so look at this guy. I'm gonna share my screen. Oh, actually, it's already shared.
Yeah,
Okay,
you're already sharing. Okay.
like we've been switching screens so much. Okay, so you know this guy, right? Like this is a non-linear. This is non-linear right here.
Okay.
The reason why it's non-linear, look at this guy. Look at the y.
Yeah.
It's raised to something not one, right?
Mhm.
And then look at this linear equation right here. Where's this linear equation? This is a linear equation. You see this guy?
Yeah.
What are you taking a derivative of?
I mean, x squared is a nonlinear.
No, but then that's not what you're taking a derivative of, right? What are you taking a derivative of?
Oh, with respect to y.
It's respect to x, but then you're taking a derivative of y, right?
Okay, so
It's
you would
just
have a x squared dy dx or
this y prime. What is this y prime? Dy dx, right?
yeah. Or
So that y, the thing that you're acting the derivative on. The with respect to is x, but you're applying the ddx to y, right?
Just that out.
Yeah, these are like I had this question before too. Like these are good questions though.
dy dx. Okay, so y. So anything that it's prime is basically the top part of like the differential kind of thing. So
Yes. Yeah. If that thing, the one that has primes in it, if it's not raised to any, not even the primes, like the variable is y here, right?
Mhm.
This y right here, this is 0 prime, right? 0 prime, isn't it? This is 0 prime, right?
What do you mean 0 prime?
Like it doesn't have a prime. It's a zero derivative. It's just y,
Okay.
right?
Yeah.
Isn't that correct?
Yeah.
This guy
It's
right here is
it's
like
a non-derivative.
non-derivative, but it's still a zero. It's a zero derivative, pretty much in this. So this guy, and then all of his other counterpart degree of derivatives, y prime, y double prime, if they're not raised to any power but one, then that means it's a linear. If they're raised to anything but one, so like this guy right here is raised to 1/5, right? This guy's raised to 1/5, right?
Yeah.
Then it's non-linear.
Okay, and just a random question that popped up in my mind. So, you know how whenever you use like higher order derivatives, like, to the second, to third, fourth, fifth, and they always put that variable up there, I mean, that number for the order. How do you know the difference between an order versus a regular exponent?
Usually, they put it in a parentheses.
Parentheses, okay.
If they put it in a parentheses, or you should clarify, like, what the heck is this? If
Yeah.
it's over like 3, I know they usually put like a 4, like a number.
Okay, so x within parentheses 2 is second order, and then, but just not. It's just a parabola. Okay.
Exponent, yeah.
Yeah.
Okay, so that one's good. Let me look at the other ones. There was another. Did you have other questions in this guy?
See, I don't know. It's been a little while. I guess the separable versus non-separable.
Oh, this guy right here.
Yeah.
As I remember, okay, so let me see. Determine whether the first order equation is separable. Usually, because you use separable, you don't really use it as much in like ODEs. You'll use it more in like PDEs.
Okay, yeah, it's more of a niche thing, but yeah.
But
anyway.
like for this one, they don't even have that one, right? Like the answers are neither linear, neither.
Yeah. So what would a separable one look like? I guess is my question.
Okay, let me just take a look at this. So it says neither separable or linear. It's neither ones. It's not linear because y is raised to a power. That makes sense. A separable one is one where you can write them as like in terms of y and in terms of x only. The reason why it's not separable is this x right here, this ex. I think that's the reason why. If you can separate them so that one side is only y and one side is only x, that's separable. If you can't do that, then they're not separable.
So it just has to do with different variables. You can have like a 2y and it's still separable.
Yeah, but then like, you know what I mean by putting them on the left hand and the right hand, right? Like when you have like this equation, if you tried your best, you can't make it so that the left hand side is only in y and then the right hand side is only in x.
Okay, yeah, because you can't divide anything. You can't separate those x squared, y squared by dividing y squared on both sides.
Because the moment you do that, then you're gonna have like a division with like y and x in it.
Okay, you're just moving it around.
Pretty much, and then like at linear, you already know what linear is.
I don't know. I'm just thinking, like, would it actually be possible, like, if we just had y's on one side, but you had an x squared, y squared on the other? Would that be considered separable because you could divide y's on both sides, and you would just have an x squared on the right?
Say that one again. So that the what do you have on the other side? X squared plus what?
So let's say on the left side, you just have one variable, y.
Okay.
On the right, no e to the x, y, or anything, just simple stuff on the left side. But on the right side, it's equal to x squared, y squared. Would that still be separable?
X squared plus y, x squared plus, or like
no, x squared times y squared.
That's separable, yeah, because then you can divide. you can divide out the y squared, right?
Yeah. Okay.
And
That
then
makes sense.
it will be 1 over y, and then you have equals x squared. So it's separable.
Okay.
So yeah, you got it. You got this
You would
one.
just have to check both sides. Okay.
Yeah. It's just the separable one right now. Did you guys use any change of variables and separate, to solve an equation? I don't think ODEs you use that. You use that for PDEs only. Like when you use
Okay.
separation of variables. You usually use separation of variables for PDEs.
Okay. I don't remember. I'll check whenever I get the review, and also look through the homework too, the older ones, and see if there's anything that looks like that.
Oh yeah, this thing right here is also one. When like besides
Yeah, the x plus y.
this thing right here, you know how the u is inside the cosine.
Mm-hmm.
If the u is inside a cosine, not only is it raised, you know how like when I said it's raised to like something not one, then there's a function acting on it. So that means it's nonlinear as well.
Okay, yeah, because you're having multiple variables.
This guy, the one that you're acting on is the u, right? That's your differential equation main variable u, right?
Yeah.
And it's inside a trigonometric function. It could be inside also a like a natural log or hyperbolic whatever function.
Mm-hmm.
And if it's inside, then that means that it's nonlinear. Not
Okay.
only that's like something that you will see, and you just have to like look into it. Yeah.
Yeah.
Like for these ones, like we're looking at these guys right here. Like the first one here is linear, right?
dy.
This guy right here is linear.
I mean, there's a t times dy dt. Wouldn't that be like a t times a y?
This guy?
Yeah.
This guy right here is like, it's okay because your y, the thing that you're trying to raise to like a derivative or like to get a derivative of is not anything but 1. T, this right here is okay, right? We've seen this before. This is just variable coefficient, right?
Yeah.
The t right here is what you're taking the derivative with respect to. With respect to doesn't matter. It's only the variable you're taking a derivative of.
Okay, so it doesn't matter if it's an x, y prime or something.
Yeah, but I think let's step back. The main question to ask first is what are you taking a derivative of? It's y, right?
Mm-hmm.
And then once you answer that question, you look at this equation. And the next question is any of my y, degree of derivatives, are they being raised to like a power greater than 1 or less than 1? And if they're not, it's linear. And then the next question is, are there any like trigonometric terms or like hyperbolic terms where that term, the y right here, is inside it? This is okay because this is t. T is the one that doesn't matter, right? T is the one that you don't care about. It's the y that you care about. So since the y here, and we answer those questions, that means it's linear because they're not being raised to a power, and then you're not using any cosine or trigonometric whatever expressions to act on your y. What about this guy, number 2?
Hold on. So that one would be, that's still linear?
The first one or second one?
Number 1.
It's linear.
Okay.
It's those two questions. You have to ask yourself, like, is your term that, the y term, is it being raised to anything but 1? And then are there any functions that's acting on it? If you answered no for both of those, that means it's linear. If it is being raised to anything but 1, or it's being, or and, it could be and or. If it's like you're having cosines or sines acting on that, then that means it's a nonlinear. Like number 3, look at number 3 over here. If you look at number 3, y is inside the sine, right?
Okay, could you have something like, instead of a trig, like let's say you had an x inside and then times in parentheses that t plus y.
Yeah, you could do that one.
So that's still linear?
Wait, what do you mean? Like you're saying that not sine but x plus t plus y?
It's like x, instead of like you erased the phrase sine and replaced it with a variable. So like an x.
An x would be like
t plus y.
Let me see. Let me think. X t in well, x would be a constant in this case, right? Or it could be some other variable. But usually, you don't have that much. Usually, there's only two variables. They're not gonna be like brutal for you. You know, like there's only usually two variables, right?
Okay.
There's usually just like the t
Yeah.
or
I
like
know.
an
I just
x.
wanted to
Yeah.
ask like a question, like, if you have some crazy one where you have instead of sine time, like sine of t plus y, it was x of t plus y. Would that
If
still be
yeah,
considered linear, or would that be nonlinear?
the thing that you want to ask is because the y right there, you know that y,
Yeah.
um, it's not really inside any function. It's just getting multiplied to x, right?
Hmm.
So that I would consider linear.
Linear, yeah. Okay, because I mean, there's no
Yeah.
power issue. Okay, so anything with
There's no
trig.
power. Yeah. Anything trig, usually that's the case. If you're multiplying, that's not really an issue.
Okay,
What
got it.
about this guy? This guy, it's a power, right? Power issue, right?
Yeah, so those would be nonlinear.
Does that make more sense now?
Yes.
Okay. It's kind of like, and then I don't know about these other ones. What are they asking?
So yeah, it's just matching them. Match this each differential to a function, just solution. Differential equations. Yeah. DNA. Yeah, I do. Like, I'll probably go through these a little later. I do still
Okay.
have a couple questions on the current homework.
Okay. Oh yeah, we're not done with it, right?
Yeah.
I thought we
Okay.
were done with it actually. Hold up. Let's take a look at. Nah, it's not showing this one.
Okay. It was the last three questions that actually gave wrong answers. On.
Let me see this one.
I'm just gonna pull up the web work again. They're gonna ask me to sign in because I
Number
absentee.
is it number 7 or number 6?
It's 6, 7, and 8. Or wait, this is homework. Okay, yeah. So let's see. Yeah, it was 6, 7, and 8. So number 6 was.
Let's look at number 6. Cause like, let me see. Find the following. You just have to find like the y primes, right? Isn't that what it is?
Yeah, it was the very last question to find the general solution.
You mean this guy?
Yes.
Okay. What did you input? Because this seems like it's not. It didn't seem like that bad.
Yeah, it was just the last one. So I put in y equals c1e to the negative 7x plus c2e to the 7x, and it marked it wrong. And I don't know why, because what you were writing, I was following along with it. It made sense. I just don't know why it marked it wrong.
Let me see. Can I see your screen?
Yeah.
Let's see. So you could share it. It'll just kick me out.
Okay. Host disabled participant screen sharing. Let me see. It says host disabled participant screen sharing.
Let me look at that one. Oh, okay. Okay, I thought I did that. Okay, go ahead.
Okay. Let's see. It's this one, right? Or no?
There's always like a bug. If it's like maybe it's like another thing where you input some. Maybe did you input it as C1 times C1?
No, I put it
Okay.
as this.
So plus 49 d squared plus so y. Okay. Well, find the general solution. It's a general solution. Okay.
I mean, this is what I put in there, and I mean it looks like it's the correct form.
Okay. Enter it as an equation. Y equals. Okay. Plus 49. So see, like, did you go over the actual, steps?
Yeah, I went along with what you were writing, and
This is usually the way you do this. So you
I
have
was just
k squared, okay, and you also have it's obviously 49. It's a minus 7 and then plus 7. Okay. And why isn't that? Maybe there's some. Let me just read this again. Find the general solution to d squared y dx squared plus 49. Did you have to complete the square? It seems like it's not even related to the one up top, though. Yeah. it would make more sense if it was related. I don't know why. It doesn't seem like it's related, yeah?
So I'm guessing it's saying if you set this as equal to negative 49y.
But then you have to transfer it over. Let me just see.
Unless you
You have
just
to
plug it in.
plug in where to where?
To plug in the, because I know you plug in the negative k squared y in. I think, no, never mind, you don't. I don't know.
Hold up. Let me see. Let me check something. Oh, I think I got it. I got it. It's not e to the 7x. It's cosine. It's cosine.
Oh, so it's cosine of 7x?
It's supposed to be c1 times cosine 7x plus c2 times sine 7x.
So there's no negatives?
There's no negatives.
Okay.
Try that one. Because it's supposed to be related to the one you have up top.
Yeah, looking at B, that's the way it was. So maybe, I don't know. K was 7.
Did you input it?
Yeah. Okay. So it was just, I guess you would find your K's.
Because like I'm wondering about this one. Like, I did 1, 2, and 3, but then I didn't even use those, right? 2 and 4. I didn't use those in 4. So what I'm thinking about that is just maybe you have to put in what you used previously, you know? So like if you had, let me see this one.
So I guess you take B, and then you, in order to find D, you need to do an extra step, which you do in C. And then from there, you use your C information, and then as well as additional information they provide in D, and plug it into B to get your answer.
Yeah. Hold on, let me just see if what the k squared plus 49. Okay. Okay, I did get it wrong. I see what I did. I see what I did now. You know how like I solved for this equation? I was doing this so fast. You know what time I did it? This was like super late. But you know that k squared plus 49?
The k squared plus 49, yeah.
The k's that you get is supposedly plus or minus 7i, yeah? Where like do you remember, no, this is a complex root. This is not like a distinct real root. So the answer, right? Do you remember talking about that one?
Distinct real roots. Okay. Yeah, I remember you mentioned that, but I don't quite know about the distinct linear roots or distinct real roots, repeated roots, or iterated roots.
Okay. Let me share back my. So you did, okay. You got it right. That's good. I wasn't looking. Let me just share my screen first.
Okay, let me stop my share because you can only share, one person can only share at a time.
It kicks you. I think there's like an automatic thing. Can you see mine now? Okay.
Yeah.
Okay. So you know how like this guy right here, this guy, right? Like I said, like the actual roots is actually imaginary, or like a conjugate, complex conjugate.
Oh, it's a 7i.
Yeah, I was doing this so fast, like in the evening, and I was like really tired.
Okay, so it's 7i and negative 7i. Yeah, I mean, is it because you have some square root in there, or how did you get that?
Yeah. Look at it. Like obviously, right? K squared equals negative 49, right? This guy right here, right?
K squared plus 49 is 0. Okay, so this k squared plus 49 is 0.
So once you do that, you just take a square root. So k is the square root of negative 49, right?
Yeah. Okay, so then just that idea about
like
the plus
7i.
7 and the k minus 7, just ignore it and just fix that part, I guess.
You don't need to actually even apply 1, 2, 3. You just have to solve for it. And then so remember the complex roots. What was the solution for it? General solution.
So the general solution
Is this guy,
for
right?
general solution
Yeah.
is equal to negative, well, the general solution to the d squared y over dx squared is equal to negative 49y.
Yeah. But the general solution is, if you look at this is 0, right? And this is 7.
0 and 7. Okay. Yeah.
So the general solution is whatever is in front of this guy, you put it on the exponential. And whatever this number is, you put it in this trigonometric functions. And then since e to the 0 is 1, you just ignore it. And so that's why the answer is C1 cosine 7x. Right?
Okay.
That's the
Yeah.
reason why.
Okay.
That makes sense.
Yeah,
Yeah.
I like to draw a lot of diagrams, so just kind of seeing that helps. Okay.
No, that's
Man,
good.
yeah, I really appreciate this. Number
What about
7.
what about 7? Yeah, let's look at number
7,
7.
it's just straight up you're wrong.
On this one? Really?
Yeah, and I'm like, I don't know why, but on
Let me.
number 7, let me go
You
ahead and
you don't have to guess on this one. You can actually solve this one, right?
yeah,
What
but like I put in negative 1/2 e to the negative x plus 1/2 e to the x, and it just says you
e
have
to the.
attempted this problem 2 times.
Okay, don't attempt it again. Let
Right.
me find the.
Well, I
Let me
mean, I
look.
have an unlimited attempts. He doesn't penalize for new attempts, so it doesn't matter
Oh,
too.
oh, really? I didn't know that
Yeah.
one. That's so weird. This problem I know is like a little bit. I thought it was easy because like you only have this f. F is like a function, the same as y, right?
Mm-hmm.
But why is it wrong? Let's see. F of x for all x in its domain. And that's why I made it like y, because it's pretty much the same thing. Okay. Minus y. Plus y. Let's look at this again. Oh, maybe I think I know. I think I know now. I think it's the same thing. I was I was doing this again where, do you see my screen on this one?
Yeah,
Okay. So you see this guy, k squared. It's the same thing. It should be minus 1.
-1.
So
So
what is it? What is this guy?
1i.
And then so it's 0 and 1. So this guy right here is going to be yx equals c1. The e doesn't matter. It's just going to be the 1. So it's going to be cosine x plus c2 sine x.
Okay.
Right? Okay, let's take a look at that, because that's not what it's asking. It's asking you for the particular solution. So now let's look at c1 and c2. So let's see. So this guy should be c1 cosine x plus c2 sine x. And then so this one is it's minus c1 sine x plus c2 cosine x. And then you just apply this. I think this is a good practice actually, because like it asks you for the whole thing. So let's take a look at what this actually equals. So you apply that, right, to like the yx equation. C1 cosine of 0 plus C2 sine of 0 is 0. And this is 1. So C1 equals 0, right?
So 1 equals 0. Okay.
Okay, so C1 equals 0. So that's good. So now you can look at like y prime. Let's take a look at y prime. Then the next initial condition. Let's look at this guy. Let's see. It's minus C1 sine of 0 plus C2 cosine of 0. C1 was 0, right?
C1 was 0.
Yeah, you got that from the first initial condition.
Mm-hmm.
So now you only have C2 cosine 0, which is 1. So C2 equals 1. C2 equals 1. C1 equals C2 equals 1, and then C1 equals 0. And then plug that back into your equation. Plug that back into your equation, and then what do you get? You get y of x equals, so that's 0, right? Oh, I see. So it's just sine x. It's just sine x. Try that one.
Okay. Let's see. You just okay. And then let me just go back to the thing here because okay, so sine x, f of x is sine x. Let's see. Yeah.
It's right.
Yeah.
Oh
Okay.
man, see, when you're tired, like I don't know, I thought you could do this. This is like very basic, k squared plus one equals 0. It's not
Yeah.
k plus one, k minus
It's k
one.
plus 1, k minus 1. Yeah, the imaginaries get you. Okay. So then,
Funny.
oh boy. And then the last one.
Okay,
Okay. I think it's just because I didn't quite.
this last one actually is like one of those like weird ones. Like
Okay.
I'm hoping he doesn't post any of these. What I did here, because you already know how to do 2 and 3, right? Look at 2 and 3. Those are
2
simple,
and
right?
3. Y double prime plus y.
You know how to do that one. It's
So you
constant coefficients.
constant coefficients, you would just do Wronskian and then.
You don't have to do the Wronskian. You just solve for the general solution.
Okay. So general solution.
And then like the solution you get is going to be, they're giving you one of the maybe a solution that can match your general solution. So it has to be kind of like a form. So you have to like kind of like observe and match. So but then it's still the same thing. You're just solving for like general solution.
Okay.
But then 1 and 4 are a little difficult, right? Look at 1 first. Like number 1 is a little difficult, right? So
Yeah.
like there's sometimes like no way of really solving these ones. You could apply what we talked about, the reduction one, right?
Yeah.
There's another way of doing it. I did it as another way. I actually got the answer.
Okay. So
And
let me
this,
see.
yeah, like the way I did it is it's not bad, but it's just doing some tricks.
2x squared 3. So then negative y is 0. And yeah, I was able to get them all in. So thank you for that. I appreciate it a lot.
Okay. Is it already due?
No, it's due in I think 30 minutes from now. But I got it all done. Plugged.
Oh, you got it all done. That's good. Okay. I think we're good
Okay.
then.
Yeah, I'm just trying to, work through these and understand them.
It's not that bad. So for this week, you're gonna focus more on the math then, right? Or like because you have a test. Do you have a test for chem?
The exam for chem, that one, I don't think it's going to be this week, maybe next week. I'm not sure. Test 2.
Okay. So like I'll still do the T8, I think, or whatever. What am I on now? T9? Was it T9?
I think it was T8 or no, T9. Yeah, T9 is.
T9, yeah. So I'll do T9 exercise and then T10. It doesn't look that bad, so I'll do that one and then homework 6. You guys already got homework 6 part of the exam?
Homework 6, I think so.
I didn't take a look at that one yet.
Yeah, I didn't really either. I mean,
is it long? Let me take a look at it.
it's longer, yeah. He says, oh, it's not bad. It's only like 12 problems, I think.
Oh shit! It looks like it's a long one. Okay, but you said it's not bad, so let me see.
It's 11 problems.
This one
At least they're all worth the same, so that's nice.
Man, you guys really get so much problems for your math, man. It's a 6. So is it from the exam 1 to 6? Is it this exam, right?
Yeah.
Okay.
There's probably 12 homeworks.
Okay, that's not bad. So two exams. Okay, for Tuesday, let's. Do you want to talk about math or chem?
Either one is fine.
Okay.
Since we worked with math here, I'm guessing probably chem.
Yeah. Okay. What I'm trying, like, I want it to be like more like, for chem. I'm just gonna talk about the exercises. I'll do them, and then if you have questions about like, I'll kind of peek through the CTQs, but not really do them.
Yeah.
Yeah. It's not that bad, but like if you have questions, let me know ahead of time if there's anything there that's like difficult.
Yeah, and like it really doesn't seem that bad because it really seems like Gen Chem with physics 1 or something. Like
Yeah.
but yet it's still difficult, and I don't know why.
You mean like when you took Gen Chem?
Like it feels like I'm doing Gen Chem again, but with
It's not really
physics,
like
it
the
doesn't
one.
feel that bad. But for
No, it's
some
not.
reason, it's giving me problems.
Yeah, it's not. It's not. Like, I always look at it this way. Like looking at like taking so many classes already. The chemistry is just physics. You know, it's not like a something else. You know, like
Yeah, and then
physics.
physics is applied math, applied calculus.
Yes, yeah. Like physics is like that's why I love physics because
Hmm.
it's everything that like you apply math and then chemistry. I think biology is like the one that's not really there. It's usually chemistry. It's just thermodynamics. It's like
Hmm.
mechanic. You have mechanics. You have electromagnetism, right? And you
Yeah.
have thermodynamics, and then you have quantum mechanics, right?
Hmm.
So that's all the physics, like classical physics, and then you have like other stuff, the modern physics.
Yeah,
But
and then linear algebra. I was looking at one of my friends who's taking it. There's
how
literally
is that? Yeah.
how to balance an equation with matrices.
How does it look like? It's not bad, isn't it?
I don't think so because I'm not taking linear algebra, but he was just showing me a picture of um, what
Yeah.
he was doing, and it was literally how to balance an equation with like a chemical equation using
Yeah. Matrices.
matrices, and I thought that was really interesting.
Yeah, you could do a lot of things with matrices because like the reason why you learn linear algebra, I thought in the beginning when I was first taking it, it didn't matter, but they always said because when I took it by itself, and I took another class where like there was differential equations and linear together, and then that's really when it made sense. Like, oh, so linear algebra is really just a way for you to relate, things as a system of equations, solving systems of equations, which you could
Yeah.
do in a chemical equation, right?
Uh-huh.
you can you're solving different like line states until you finally solve like it gives you multiple things in a very succinct way. You don't have to do the substitution. You can just like there's different techniques in linear algebra that really simplifies you solving linear equations. And
Yeah,
then,
this is what he showed me. He just took a picture of it, and that's what he was doing.
let me see let me just enlarge this one. Oh, okay, I've done that before. Yeah.
Yeah, it's neat.
It's nice. Maybe you should take that. I was taking if you take that class, do they have like a software aspect? Like what do they learn like MATLAB or
See,
Mathematica?
I don't know. I know he's used Python.
Oh, you use Python for that class?
Well, I don't know for that class, but had to use Python for some of his classes for his astronomy classes because he's wanting to get into meteorology and astronomy. So I thought that was kind of
Oh,
neat.
I didn't. That's nice. I didn't know you can. Yeah, Python is like. Oh, do you know how to do Python by chance?
No, I'm just saying like some of the classes he was taking, he was using Python for, and I don't know which ones.
Yeah.
But I just thought it was kind of neat. I don't know. Maybe you use it in there, maybe not. I'm not
It's a
sure.
little weird, yeah. Like now that you're saying that, because like astronomy, like where do you use it? But then again, it's like a science.
Yeah, the
There's
eclipse
always some coding, you know.
calculations. Yeah, eclipse calculations, calculating eccentricity of orbits and things
Yeah,
like that can be done with Python. So it's
yeah.
kind of
Okay,
neat. But
hi
yeah,
Ben. Let me yeah, just send me all the new stuff, and then I'll send you the next chemistry and then homework 6.
awesome. Thank you so much.
Yep, and then yeah, let's talk more about it on Tuesday.
Okay, sounds good.
Same time, same time. Cool. And
Alrighty.
have a good one.